All right, we're back. We are on page 9 of notes to, nope. We're on page 4 of notes 9. Why can I not do that? Okay, so you know what the other thing is? There's a 9 in this problem, so like 9's all over the place. All right, let's see if we can do it. Find the slope of f inverse at x equals 9. So x equals 9 is an x value for f inverse. If f of x is this. So in my experience, these questions are usually non-calculator. If they are calculator, it's just like, it's totally fine. But usually they're non-calculator, and usually it's like guessing. So like I need to first, this is an x for f inverse. So y for f of x. So I need to figure out what value I plug into f of x to get -9. So I just solve this. X cubed plus 3x plus 5 equals -9. So I need to solve that. But since I'm just going to guess, I usually start by guessing. So if you have to guess, plus or minus 1, plus or minus 2, maybe plus or minus 3, but like honestly, it's almost always one of those. So here I'm thinking it's going to have to be a negative, right? So let's go with -2. -8 minus 6 is -14 plus 5 is -9. So I'm just going to say x is -2, and that was definitely a guess. But it's always going to work. So we want the slope of, okay, so now what do I know? I know that -2, -9 is on f of x. And that means that -9, -2 is on g of x, which would be f inverse of x. So g prime of -9 is going to be 1 over f prime of -2. That's it. Every time, you just think your way through it. We found this. Write down your ordered pair for f of x, then write down your ordered pair for g of x, which is f inverse, and then g prime of whatever's here is 1 over f prime of whatever's here. That's it. We didn't actually do the problem yet, though. So f prime of x is 3x squared plus 3. F prime of -2 is going to be 4 times 3 is 12, plus 3 is 15. So this is 1 over 15. And that is our answer. Okay. So that's the slope of the inverse at x equals -9 on the inverse is 1 over the slope of the original at -2. Let's try this one. Find the slope of g inverse at, so this one I'm just trying to mess with you, I think, by calling it g inverse. The inverse of g of x equals this at x equals -7. So the first thing we need to do is we need to solve 6x plus the cube root of x is -7. So imagine if you couldn't guess this, you're done for. Like, I don't know what you're going to do, but -1 definitely works. So x is -1, got it by guessing. So -1, -7 is on g of x. So that means that -7, -1 is going to be on, I'm going to call it f of x, and that'll be g inverse of x. So f prime of -7 is going to be 1 over g prime of -1. Now we have to actually do the problem. So g prime of x is 6, and then we'll do 1/3 x to the -2/3. G prime of -1, imagine plugging anything other than 1 in here, really, is going to be 6 plus 1/3, right? Because you're squaring the -1, like you take the cube root, you get -1, but then you square it, so it's back to +1. 6 plus 1/3, which is 18 19/3. So 1 over 19/3 is 3 over 19. Okay, pretty good. I'm going to show you how to do this one on the calculator, just because we haven't done one yet. And honestly, I didn't look ahead. I don't know if there's a calculator. There's got to be a calculator problem somewhere. But anyway, I'll show you how to do this one on the calculator, and then we will call it a video for this one. So let's see. So I got this. I'm gonna make this bigger. I don't know what impact that has in the actual video that you're watching. It's bigger on my screen now. So our new document, whatever. All right, so g of x is given to be 6x plus the cube root of x. So I'm gonna do x to the 1/3. Okay, first thing I did was I solved g of x equals -7 for x. Okay, then I found the derivative with respect to x of g of x at this x value we just found, so such that x is -1. Then I did 1 over that answer to get 3/19. So that's how you do them on the calculator. It's worse when the numbers are gross because then you gotta like store values and deal with that stuff, but not bad, right? So I'm gonna end this here. I'll be back in the next video to do the second half, it looks like, of this page. So I will see you there.